So let's take a look at the semi-diurnal tidal cycles, like we mentioned earlier on. For the most case, you have dominance of, semi-diurnal or mixed semi-diurnal tidal cycles in most parts of the world. That means in one day you have both high tides and low tides, but two of each of them in most locations. So the question here is, why is that so? Okay. So, first thing to note, or first thing to kind of refresh our mind, that the Earth rotates about its axis, makes one complete rotation about its axis every 24 hours. Another thing to note again is that the Moon revolves around the Earth in the same direction, along which the Earth is rotating. The Moon is also revolving around the Earth in same direction, and it takes the Moon about 29, 28.8 or 29 days from all I've seen from different researches, about 29 days to complete one revolution around the Earth. So, recall what we said about the gravitational pull of the Moon on the Earth. So that creates what is called tidal force, and that tidal force leads to the creation of two bulges, right, on the two opposite sides of the Earth. The part that is directly opposite the Moon, right, and the other far end of it. So those bulges are as a result of the gravitational pull of the Moon on the Earth's ocean, and areas that experience those bulges typically will have high tide at that time. So what that means is that as the Earth keeps rotating round about its axis, um, different parts of the Earth will be experiencing, that tidal force or bulge as it keeps moving from one part to the other. So another important point to note is that successive, high and low tides are separated by 12 hours, whether it's semi-diurnal or mixed semi-diurnal. The key thing is that from one high tide to another high tide, and from one low tide to another low tide, they're typically separated by about, approximately 12 hours within a 24-hour cycle. So now let's take a look at this, more like same thing that we've said, but in a visual sense of it. So imagine that this is the Earth in the middle, and the Moon. Of course, the Earth rotates about its axis, while the Moon revolves around the Earth. And recall that the Moon takes 29 days to make one complete cycle around the Earth, and the Earth is on its own just completes one rotation in 24 hours. So what this means is that if we move this, while the Moon it's orbiting around the Earth, before about it covers about 13 degrees, approximately 13 degrees, um, coverage, the Earth will have completed one cycle. Okay, and the question is, how did we come about this calculation? It takes the Moon 29 days to make one complete cycle or revolution around the Earth, which is 360 degrees coverage, okay, for it to go round. Okay, so what that means is that in one day, the Moon will have done about, just if you say 360 divided 29, it's about approximately 13 or 12.13 degrees. So that means while the Earth is yet to complete one, um, while one complete rotation about its axis, which takes 24 hours, which is one day basically, the Moon will still just be in about same position with just a difference of about 13 degrees between where it was. If you consider this little arc that the Moon has made, right? It's just about 13 degrees. So that means at time t1, if this part of the Earth is experiencing a bulge or a pull, because of course it's directly um, close to the Moon, and the other part opposite it is also experiencing a bulge, because of course it's aligned the same um, orientation with the moon. So we're going to have high tide in this location and high tide in this other location, right? But that's at time t1. So when as the moon continues to revolve around the earth, and the earth of course is making its rotation, in one day, in 24-hour cycle, this location that started at time t1, that's, let's call this location A, will have gone round and come back up to that same location where it was. Meanwhile, the moon will just have completed just 13-degree arc away from where it started, which is kind of really close to where it was. So what that means is that in 24 hours, a particular point on the earth will have experienced 2 high tides and approximately 2 low tides. And that's why if you look at the map we saw earlier on, most parts of the earth, right? I mean, most coastal areas of the earth actually have either semi-diurnal or mixed semi-diurnal tidal system.